So if you look at this electronic code book, the first mode of block cipher technique, the electronic code book, this is very simple technique, technique here. So we will perform the separate encryption and the decryptions. I already told you that for this are under the block cipher mode. So the given plain text will be converted into the binary numbers, and from there, according to the given algorithms, you will be forming the groups here. Okay, this P1, P2 are not the one or single letters alone here, but this is rather these are a group of bits here, binary numbers. So the size of P1, P2 up to Pn are all same here. Okay, these size are all similar. So you must know that this P1 is nothing but it may be of 64 bits if you are using the DS algorithm. It may be of 128 bits if you are using the AS algorithms, or maybe any other number of bits, but it is definitely a combinations of bits here, okay, rather than a single number or single bits here. So but this is the very simple block cipher mode, a simple block cipher mode of how actually we perform here. So this is a given plain text, then you will perform the encryption. You will be using any other algorithms for encryption, either DS or AS algorithm. That particular algorithm or transformations will be given. Then in that we input, what are the inputs of that encryption? The inputs are the given block of that plain text and the key here. Okay, so we'll come back what is the size of this key later on. What is the size of this key here? Similarly, so we for this particular electronic code books, we are performing the operations of every plain text individually here. Every blocks, not a plain text, every blocks of the plain text individually. Okay, there is no connections between the first block and the second block and so on up to the end block here. We do not have any relations here. Okay, so when you perform the encryptions with a given key, the particular key will be given. Actually, the size of this key will be that size of this plain text here. Okay, you must remember that the key is also not a single number, but rather it is a group of combinations of binary numbers here. The size of the key is equal to the size of the plain text here. So k is equal to the particular size equal to each and every plain text here. I mean the size are equal, not the values. Okay, only the size are equal. If it is 34, it will be of 34. If it is 64, it will be of 64 bits here. So P1 inputted with this encryption algorithm input with P1 and K, it will deliver or give you the ciphertext C1 here. So once this is over, there is nothing to do with the second block. In the second block here also, key, if you look at this k here, I have written only the same constant k here, so this k remains the same. Okay, k remains the same. So P2 again with k encryption algorithm, it will give you the ciphertext here, and so on up to the p end here. Okay, this is the last block. This is the last block, and also you know that if you are grouping, and in the last block, if there is some if the block cannot be sufficient number of bits here, then you go for the bit padding. You go for the bit padding, means adding or inserting the dummy bits here. So how actually the encryption is performed here? Usually we write in this manner. C1, if I want to get the value for C1, I have to perform encryption. E stands for encryptions here. I have to perform encryptions. What are the input inside encryptions? The key, K is the key, and P1 is the given plain text here. This is the mathematical representation of how we write the encryption formula here. Okay, these encryptions can be of any other algorithms here. It may be simple addition, multiplication, or maybe any other affine, or maybe any other DS, AS, or any other algorithms. But in this particular mode, we are not going inside the algorithms here, so we will define them as some transformations here, encryption transformations here. So in general, if I want to write for the ith block of the ciphertext, then I write in this manner, but whereas the k remains constant here, k, and the ith block of the plain text here. Okay, ith block of the plain text here. So in decryption part also, you can just write in the decryption part what actually you can write here. So this is your decryption part. So given the C1, you have to do the reverse part. C1 decryption, and then with the same key you have to perform the operations, and then you will get P1 here. And then again, for this C1 is nothing to do with this C2, means there is no feedback mode here. From this I am not getting any feedback, and from this also I am not getting any change here. So these blocks are all independent. So from this C1, and then by using the key I got this P1. Again from this C2, C2 is what we have already obtained in the previous encryption technique. So encryption of the plain text block 2. Here by using that block 2, I decrypt it, we decrypt it using the same key, and then we got this P2 here. So if you look at this manner, the key remained constant throughout the encryption technique, and that same key we transfer to the encryption, to the decryption, and then that particular key also remain constant throughout the decryptions here. Okay, so if you want to write the plain text, how actually you got this one? So you got this one by decrypting what are the inputs K and C1. So if you want to write for a particular ith block, then you can write as P, K remains constant, and then Ci here. This is the formula for decryptions here in case of the electronic code book. So if you look at this electronic code book mode, there are some disadvantages. So what are the disadvantages you can see? So when we group the plain text into some certain bit, for example, say 64 bits, so certain P1, the same pattern of P1 can be repeated somewhere else. Okay. May or may not be repeated. May or may not be repeated. For example, if P1, the same pattern of P1, pattern means C. If I am taking the P1 to be certain blocks like 1 0 0 0 1 0, okay, 1 2 3 4 5 6 bits here. Then the same, if I am grouping the streams here, I can get the same patterns. Okay, I can get the same patterns of P1 and P2 here. So if I'm getting the same patterns of P1 and P2, or maybe this pattern, similar patterns can be repeated somewhere else, maybe at P17 or P20, may or may not be repeated. But if possible, if it is repeated, then since I'm using the same algorithm of encryptions and the same key, they will generate the same ciphertext here. Means the ciphertext are redundant here. There is a repetitions of the ciphertext here. So why the repetition of ciphertext is considered to be not good? Because see, when the ciphertexts are repeated, the traffic analysis can analyze, and then they can go for the retrieval of the keys here. They can guess the key by using the patterns here. If I'm getting for a particular block of the plain text, if I'm getting the same blocks again and again, if there is redundancy, then by using the intelligent method or by using the analysis, they can get the key and also they can get the plain text here. So the redundancy means the redundancy of the ciphertext should be omitted here. Okay, this is one of the drawbacks of your ECB mode. So how can we remove such kind of disadvantages in the first mode? So we'll see in the second mode here how actually we can remove the redundancy. Since redundancy is a problem, why? Because the traffic analysis can analyze the redundant data, and then they can, by using intelligent method or by using the analysis method, they can go for the retrieval of the plain text and the keys here. So this is one of the very disadvantages, and then that is why in the next mode we will try to omit such kind of redundancy. So the next mode is the CBC mode here. Okay.